Fridays. Okay. So I think I usually put it, I don't know if I change yours to Thursday or, because I have pre-calc on both even and odd day, so I just always do them on the same day.
Okay.
So I think you guys always get an extra day. Because the other class didn't have their homework assigned until the day after you do. So yeah, so a couple things. We are going to look at lecture 16 today. I guess it says homework due, but I think it's actually due Friday. I'm not worried about it anymore. And it's just lecture 14, and then 15 is due next week, and then on Thursday of next week, we are having a quiz. Now, what's the rule on quizzes?
You can use your notes.
All notes, all homework. So when you take the homework, you take a picture and you upload it, don't throw the homework away, keep it, because you can use it on your thing. Now, I won't be giving you like a practice quiz or something, like I did in Algebra 2, where I give you like quiz version A and then quiz version B is the actual. I'm not doing that, but I will tell you what's on the quiz. What questions are on there, what things you probably need to look over, what things you have to make sure you have your notes on and stuff like that. So I will tell you that next week. It is over lectures 14, 15, and 16, so it is included today. And there won't be anything on the quiz you haven't already seen at home.
Morning. Miss G said she's going to email you.
All right. Guys, over at taking attendance break. So let me repeat what I said for our latecomers. No, today we're going to do lecture 16. Next Thursday we have a quiz. Quiz is over 14, 15, and 16. On Tuesday I will tell you exactly what's on it, but I will not be giving you a practice quiz. Remember last year I gave you a version of it. I'm not doing that in pre-calc. Way too much work. So, and quizzes are usually much shorter. But do remember, okay, when I give you a quiz, it has to be done in one sitting. So you take it. This quiz is very short. It's not going to take you more than, it shouldn't take you, honestly, I don't think it should take more than about 10 or 15 minutes. I'm going to give you a good 30 to finish it. Okay, so it shouldn't take you that long to finish, especially if you've done the homework and you know what you're doing. Okay. All right, so lecture 16 was what we're going to look at today. Complex numbers. Any questions from homework we're going to answer? Yes?
So this is the only homework we've had so far, right?
14 and 15.
Okay.
Yep. And I don't anticipate this taking us super long, so you'll have time to work today as well, I hope. So. And here at the beginning, a lot of these are going to be a little more review. So. Very good. All right, so what is a complex number? Lecture 16. What is a complex number?
Stuff like
imaginary numbers.
Imaginary, very, very good. So, we know definition of real is any number on the number line. It includes natural, it includes integers, it includes rational, it includes basically all real numbers. Rational and irrational. I should have put irrational in there. There's no little symbol for irrational, so we just have to write it out. Irrational. So all those things are real numbers. So if we think about a number line, 0, 1, 2, -1, -2, any number that can be placed on the number line is a real number. Okay. But then we have this world of complex, these imaginary numbers. So imaginary numbers are actually going to, or could be graphed on a horizontal line. So here we have our x and our y. We also could have our real and our imaginary. Real and imaginary graphs. Okay, so what is the only imaginary number? Roman numeral 1. Imaginary number is I, which equals what?
-1 in a not a radical.
Uh-huh.
Oh,
It's the square root of -1. Why is that not real?
because you can't have negative in a square root.
So you can't have the square root, because the square root means it's the same number of times itself. So like 2 times 2 is 4, square root of 4 is 2. 3 times 3 is 9, the square root of 9 is 3. You can't have the same number multiplied by itself and get a negative number. So it's not real. But yet we do have them in different applications. Anyone here going engineering? You're going engineering field, right? Okay, electrical engineers deal with imaginary numbers all the time.
Yeah.
Okay, so you will definitely see that. Okay, now, if you remember, I think which one, no? If you remember from the last year, we talked about, there's like a pattern, right? We have I to the first, this is square root of -1. So then what is I squared?
Was it -1?
It's just -1, because it's the square root of -1 times the square root of -1, which is -1. So whenever you see an I squared, you replace it with -1. Okay, what about I to the third?
1.
Nope.
Negative, or square root.
It's negative something.
Square root of -1. Or is it just -1?
Nope. Because I squared is -1. Yes.
Is it like -1 on like the little part of the radical with the -1 in the radical?
I don't think so. It's just negative I.
Oh, okay. I remember
Because
now.
remember, it's going to be like
Yeah.
I times I squared
Yeah.
is I to the third. So I cubed is just -1. And then now I to the fourth, that's going to be
1.
1. Right.
Okay.
So then what's I to the fifth?
Negative, or square root of -1.
It's just back to being, it's like saying I to the fourth times I, which is going to be 1 times I, so it's just I. It's just the square root of -1. And then I to the sixth,
Just
-1.
just -1. It's the same. And then I to the seventh, negative I to the eighth equals 1. And it just continues that cycle over and over and over and over and over and over again. I think last year we did and I don't know why honestly, I've actually asked engineers about this. I've asked math people this. I've asked, okay, so why is it on ACT every year they have a question that says, what is I to the 323rd power? Okay, so it's really easy to find because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You just have to figure out where it lands, right?
Yeah.
So we take 323 divided by 4. Oh, 0, 3. So remainder of 3. So it's 1, 2, 3. And you just simply look, this doesn't matter at all, you just figure out what the remainder is and where it lines up. There's no application of that ever, but it's on every ACT. Okay? So I'm not going to test you over it, but if you're taking an ACT test, we did it last year, that's kind of how you do it. Just divide by 4, see which one it lands on. It's the number sense question. All right, I've got away from my notes a little bit. Let's go back to my notes. Okay, but you should have these 4 written down and know those for sure. Okay, so Roman numeral 2, if you will, the complex number. So we're going to ask you to write all of your numbers in complex form, and that's going to be A plus BI. So you have the real part first, plus the imaginary part. So we would look something like 2 plus 3i, or -7 minus 4i, something like that. Everything will be written in that form. Complex. So if we simplify something, let's say I give you the square root of -25. How do I simplify that? Remember from last year, what did I teach you to always do first with a negative inside the radical?
Swap it.
Not swap it. Say it again.
Square.
Well, kinda.
Don't you just do the opposite of square rooting?
Which is,
Oh shoot. Just squaring it.
okay, if I'm trying to solve something, that will come in handy. We'll do that a little later. But in this case, we're just simplifying.
Yeah.
So I'm going to break it apart. And remember, there's a negative
Oh.
underneath. Always take the negative out
Yeah.
first. So always take -1 times the square root of 25. So then my -1 becomes I. The square root of 25 is 5. And I have an answer of 5i. So if I write it in complex form, that's perfectly fine. You don't necessarily need to write 0 plus 5i.
Okay.
You don't really need to do that. You can, but you don't really need to. But whenever we're trying to simplify, just take that negative out first. I'm actually going to show you a little tricky one here a little bit later. We need to be careful with. Okay. Under operations. All right, now, I'm not going to spend a lot of time on part of operations, because that should be a review as well. Operations with complex numbers. If you remember, if I'm adding, if I'm taking something like 2 plus 4i plus 6 minus 2i, something like that. What do I do with complex numbers? How do I add them?
Combine.
Combine what?
Like terms.
That's it. Combine the reals with the imaginaries, just like pre-algebra combining like terms. It's just the real 2 plus 6 is 8. 4i minus 2i is positive 2i. And it is as simple as combining like terms. Subtracting is the same way. I'm not even going to put an example up here because we've already done it too many times. Subtracting is exactly the same way. Distribute out that negative sign, just combine like terms. Combine like terms. The issue is going to come when I multiply them. So if I have to multiply two complex numbers, something like 2 plus 3i times 4 plus 5i. I didn't even do that on purpose. 2, 3, 4, 5. There's an accident. Okay, so when I multiply with complex, what's it look like? Yeah.
Don't you take out the I and then like put it as 3 radical -1 and then multiply those two and then multiply the other ones?
You just distribute.
That's way more complicated. What'd you say?
You just distribute.
It's just like FOIL.
Oh.
It's just like if it said 2 plus 3x and 4 plus 5x. But there's one difference at the end. Okay? So FOIL just like normal.
Okay.
2 times 4 gives me
8.
8. 2 times 5i gives me
10i.
10i. 3i and 4 gives me 12i. 3i and 5i gives me 15i squared. Because I times I is I squared, right?
Mm-hmm.
So what's going to be the difference from polynomials with imaginary numbers?
When you look at when the I squared becomes actually I squared, you change it to whatever I squared is, which it is.
And what is I squared?
-1.
-1. So I'm going to end up with 8. I can combine like terms, so 10 and 12 is 22i, plus 15 times the -1. Because remember, our form has to be a plus bi. There's no I squared in that form.
So when it's just I and it doesn't have any like power, is it just I to the first?
Yes.
Alright, I couldn't remember.
So then here we end up with 8 plus 22i minus 15. 15 times a negative 1 is negative 15. So I'm left with negative 7 plus 22i. And notice that that's in my correct form, a plus bi. So never leave an answer with the I squared. Always make that substitution. And that's really the only unique thing different from polynomials that we've been doing for years and multiplying complex numbers, is you have to replace that I squared.
Bliss.
Okay, does that make sense? Do we need to go back over that?
No, that's
Good. Just don't forget the I squared. Because we have a couple more things that get a little more complicated. And that is when we divide. When we divide. Okay, so in order to divide, we have to use this thing that Ellie was just reminded of in calculus, the conjugate. Remember talking about that? So let's talk real quickly, make a little note to the side here. What is a complex conjugate? It comes up quite a bit, actually. Okay, so let's take any number 2 plus 3i. And does anyone remember what the conjugate is?
I don't.
Ellie, do you remember? Trying to review a little calculus here. Because we did it right there. I did it back there with you and Babacar.
Isn't it like, oh my goodness, it's like 8 in the morning, okay?
It is 8 in the morning. Okay, so all you're going to do on a conjugate, okay, however you need to write the notes, is I'm going to take the imaginary part, change its sign. So rather than 2 plus 3i, I'm going to change that plus to a negative. So it's 2 minus 3i. And so we're going to change the sign of the imaginary part. And of course, the obvious question then is,
What next?
no, before the what next thing, the obvious question would be,
Subtract.
no,
It's not in the same, it's not in the correct format. It's, you said a plus bi, now it's minus bi.
okay, that's, honestly, that's the same, it's the same as 2 plus a negative 3i minus a plus. You don't really add, you subtract a negative.
We just make it a negative 1.
I'm sorry, what?
Or I don't even know.
Did you,
Never mind.
These just mean the same thing. He was saying because it's supposed to be a plus bi. Well, a minus bi is the same thing.
Yeah.
Okay. So no. So the question that I was hoping someone would ask is a one-letter word.
How?
Why? You know,
Yeah.
the letter Y.
Yeah.
Why? Why? Why do we use a conjugate? Okay, watch what happens. If I take 2 plus 3i and I multiply it by 2 minus 3i, something magical is going to happen. All right? Are you ready for the magic? All right? Do you remember what happens?
Doesn't it just, it's just gonna stay the same?
No, absolutely not.
Absolutely.
What is
not.
2 times 2?
4.
4, very good. What is 2 times negative 3i?
Negative 6i.
Outstanding. What is 3i times 2?
6i.
Oh. What's going to happen to those two?
It's just gonna
It's
be
gonna cancel
I.
each other out.
They're going to cancel each other out. It's going to be 0.
Oh.
Okay? And then 3i times negative 3i gives me negative 9i squared. So negative 6i and positive 6i will always, the two middle ones will always cancel each other out. They go bye-bye.
Oh.
So then I'm left with 4 minus 9i squared. And then what substitution do I make?
you have to make
Negative
this
one.
negative one.
Negative 1. So 4
Oh,
minus
okay.
9 times
Interesting.
negative 1, which gives
Positive
me
9.
4 plus 9, which gives me 13. And what that conjugate will do is it will, in a sense, rationalize the root. It will get rid of the imaginary value. Okay? and it becomes, when you multiply two conjugates together, in this case, with imaginary, we'll get rid of that I, okay? And that's what we will have to do when it comes to division, okay? So, I guess another thing about this is to kind of show you, we all like shortcuts, right? Okay, so when you take two conjugates multiplied by each other, when it comes to FOIL, first, outside, inside, last, the outside and the inside will always cancel. So when you're multiplying, all you do is the first ones and the last ones. It's the only time that's allowed, is with conjugates, okay? Because those middle two will always cancel out. All right, so a couple little tricky ones for you. Because I don't want to trick you, I don't want you to be tricked. A couple tricky ones. What if I give you 4? What is its complex conjugate?
-4.
Do you change the sign of the real or change the sign of the imaginary?
Imaginary.
The imaginary. So that's like saying 4 plus 0i, right? So its complex conjugate is just 4. Because you don't change the sign of the real one. Now, what if I give you just 3i? What is its complex conjugate? Remember, you changed the sign of the imaginary part, right? So I changed the sign to -3i. Okay. If I give you something like -4 minus 2i, what is its complex conjugate? You know?
Is it
-4 plus 2i?
That's exactly it. It's just -4 plus 2i. Okay, so once again, all we're doing is changing the sign of the imaginary part. Okay? Don't make it any more complicated than that. So then, using that to divide, let's take a nice example out of my notes that I know is going to work. So 7 plus 4i divided by 2 minus 5i. Now remember, my final answer needs to be in the form a plus bi. And Logan, if it really helps, you can put a plus or minus b. Okay. All right, now for this one, we're really not truly dividing. What we want to do is we want to get that bottom without the I. We don't like to have i's in the denominator. So the only thing you're going to do with dividing, okay, is we're going to multiply by what is the conjugate of the, remember, I don't care about the numerator, it's just the denominator. So what's the conjugate of the denominator?
2 plus 5i.
2 plus 5i. And go back to the rule of algebra, whatever I do to the bottom, I also have to do to the top. So I have to do it to both of them.
Wait.
Because what is 2 plus 5i over 2 plus 5i? What is that equal to?
1.
It equals to 1. So I'm taking a fraction times 1, so I'm not changing the value, I'm just changing the way it looks. Okay? Kind of like when we did fractions, if I have 2/3 and I multiply by 4 over 4, well, I'm getting 8/12. That's still equal to 2/3, it just looks different. Okay? So this is still going to be the same, it's just going to look different. All right, so let's go ahead and multiply. Let's see, what color should we use?
Red.
Red is so hard to see in my, we'll try it. 7 times 2 gives me
14.
14. 7 times 5i.
35i.
4i times 2.
8i.
4i times 5i.
20i squared.
So can we start just putting in -20? Is that too much?
Yeah, that's fine.
That's fine? Is that okay? Or is that skipping steps?
Nah, that's good. That makes sense.
Yeah.
It's quicker.
What do you mean by yeah?
Like, yeah, it's cool.
It's okay?
Yeah.
Okay, because whenever I have I times I, I'm just gonna put minus.
Yeah.
And then, or change its sign, whatever it's sign. Okay, on the bottom, I'm gonna do 2 times 2 gives me 4. The outside is gonna be plus 10i, The inside is gonna be minus 10i. So then I do the negative, let's see, plus 10i, minus 10i, minus 25i squared. So I can put here what?
25.
Yeah, plus 25. Plus 25. Because the two i's become a negative, which changes the negative to positive. 5 times 5 is 25. And then we just simplify. So I have negative 6 plus 43i all over 29. Now, one simple little notation, I honestly would accept that, but when you're looking at ACT or you're looking at a standardized test, NWA, whatever, they don't like this because it's not in A plus BI format. So the way they will want to write it is negative 6 over 29 plus 43i over 29. They will want it written like that. I personally don't care. Okay.
That's just pedantic at that point.
Yeah, that's kind of extra.
It's actually splitting a hair. Because if it has to be written like this, then it needs to be, but they mean the same thing. So, but you'll see that on ACT. So don't be surprised. Okay, so dividing, multiply by the complex conjugate, top and bottom, simplify your answer.
It's very simple.
Okay, let's have you try one. Let's have you try one. Because honestly, if I do this, I'm also multiplying. Okay, so I'm getting both problems at once. So let's have you try one. We good with that example?
Yeah.
All right, I'm sure you'll yell at me if I go too fast. Let's switch colors again. Let's go to blue. All right, so you try. Let's go with negative 2 plus 4i divided by, oh, I don't know. Let's go with 5 plus 3i. And then I'm going to give you a warning and be done. I'm going to change your old attendance while I'm thinking about it.
Nice.
You got done?
Yeah.
Would you like to attempt it on the board?
Yeah.
Are you okay being on camera?
Yeah.
This will be shown to everyone in the world.
Yeah, I'm fine.
right next to the pen it says erase. Yeah. Okay. So you have, looks to me like you have raised. It's just that that's the positive. Negative 10 plus 12 does give you positive 2. Because I think when you do 4i times negative 3i, that's negative 12i squared. So we make it a positive.
I probably have to I swear it's all negative.
Positive, negative, negative. And then the I squared makes it positive. And then that would give you a positive.
Would you cut me wrong since I did my work and I got the right answer?
Well, you didn't get the right answer because you did positive. You have negative.
I thought you said the 2 was right.
No, it's the right number, it's the wrong sign.
Oh, there we go. Okay, I'm done.
Oh, that is your mistake. Yeah, that is your, how did I do that? I did that. You, I believe, I have one mistake.
Dang it. It's no mistake.
It's in your numerator. And it's a computation mistake.
Is this a negative?
No. No, negative, negative, positive, 16. You see his mistake?
What's the? Oh shoot. I don't know why I did that. Why did I do that?
It's easy to do when you're doing tons of computations. Yep. You got the sign right.
Yes.
Just.
Don't feel bad. Instead of 25, I got 10. I added.
And I said it was correct. So we all make those computations.
So it's just
2 plus 26.
Right. One thing went wrong with that.
nice.
Messed it up. Good? You good? Got right answers?
Not close enough.
You were close.
I got mine right.
Beautiful.
I got it on my paper. I just didn't do it on here.
Cordell, you're good?
Yep.
Okay. That's all that? Okay. Outstanding. All right.
I know how
so
to do it.
you know how to do. You got the process. It's just 5 times 5.
Does not equal
Not 10. Yeah. But you know that. What? 4 times 3 is not 20.
Yeah,
We
it's
all make
definitely
those
not 20.
computations. It happened. Okay. So I would like to do 2 things extra. Number 1 is to warn you about a problem, and number 2 is to walk through a quadratic because you're going to see those. Okay. So here's my problem. Here's the warning. If you're taking notes, little asterisk, warning. If I give you the square root of negative 25 times the square root of negative 4, what do you think the answer would be there? What kind of makes the most logical sense?
Negative 29.
Multiply.
Oh.
Well,
100.
well, since you take out the -1, which becomes I, wouldn't it be 100i squared, which would be negative 100?
Oh, very good. That's exactly what you. That's not negative 100. It's a square root.
Yeah, that's what I was gonna say. It was square root.
Square root of 100 is
Like
10.
10.
Yeah. So what most people look at this, and the first thing they would think of, at least what I would assume, is, oh, we just multiply. So is the square root of negative 25 times negative 4. Oh, two negatives make a positive, so 100. So the answer is going to be 10, and that is not correct. Because you do have to take the negatives out first, okay? So you have to think of this as negative 1 times the square root of 25, sorry, the square root of negative 1, times the square root of negative 1 times the square root of 4. Because the square root of negative 1 times the square root of negative 1 is,
Nothing.
well, we end up with 5i times, I almost said 4, square root of 4, which is 2i, right? This is I, this is 5, this is I, this is 2. So as Logan said, I do end up with 10i squared, which ends up being a negative 10. So I just want to reiterate what I said before. Whenever you have a negative on the radical, split it before you do anything. That way you don't lose that negative sign. Okay?
Oh, okay.
Okay. So split that first. Take out that negative I first. That negative 1 first. Now I say that, and then every year we come up with a problem and we see people, so be careful. Always think of that negative 1 out first. All right.
Alright.
Last thing. And it really is a review problem. I know it's been a year since we've done quadratics. So let's solve 3x squared minus 2x plus 4 equals 0. Now the reason I'm showing this one to you is because we're going to end up with a complex root. Okay, we're going to end up with the square root that's negative. So we have to deal with that. So 3x squared plus 2x plus 4. And remember, what's our form?
Quadratic.
Okay, this is quadratic form. But what's the form of our answer?
Oh.
A plus or minus.
A plus minus bi. So that's my complex root. So that's going to be one way I put my answer. Okay.
For this?
Yes. Because we're going to end up with a complex answer. Okay. I mean, if we have real answers, that's just a number. That's just
Yeah.
12. But in this case, you're going to have a complex answer. Okay. So the way I always do it is do that discriminant first. So I always do that b squared minus 4ac, the area that what's underneath that radical in our quadratic formula. Okay. Because remember, let me jump ahead. Some of you may remember plus or minus the square root.
Yeah, that's what I was trying to say for the equation, but I didn't know I was just saying plus or minus.
Say again.
I hated that.
You hated that?
Yes. Hated.
Why?
Because it was hard.
It's helpful.
I don't care about none of that.
You need to just not beat around the bush. Just tell us how you really feel.
I just did.
That's
All right. So the first one we're going to do is b squared minus 4ac. So identify. What is a?
3x squared.
It's just the number, just the third. So what's b?
2.
Take the sign with it.
Oh, 2x.
Negative 2, not the x, the negative. Remember, it's just the number. Okay, let's see if we get c right. C is going to be 4. Just positive 4. Very good. All right. So now we just plug. Once we identify what a, b, and c are, now you just plug and chug. Okay. So b squared is negative 2 squared. A is 3. C is 4. So we just plug our numbers in, chug to the answer.
This was so easy.
Cordell, you're looking kind of.
No, I was just like, look, the light fixture was like glaring on the screen.
Does it help if I turn the front lights off?
Yes.
I don't think about that from where I stand, so if that does help, we'll shut those lights off. I don't know if that helps or hurts the glare.
Nah, it's better.
It's better.
It's better, okay. Ooh, kind of dark up here. Kind of setting the mood. She doesn't want to go there. Okay, I probably shouldn't have said that. All right, we'll delete that off. Negative 2 squared gives me 4. minus, what's 4 times 3 times 4?
So you do parentheses first, so 12 times 4 is
Negative 48.
Minus 48. So that's going to give me a negative 48. So my discriminant then would be negative 44.
What one's the discriminant again?
So the discriminant tells me what my answer is going to be. So like if my discriminant is negative in this case, I'm going to have 2 complex answers. If this is positive, I'm going to have 2 real answers because I could actually take the square root of a positive number. If it's 0, well then all of this goes away and there's just one answer. That's the discriminant. Okay, so number 2 then, let's actually plug it in. X equals, let's see, negative b, so negative 2, negative b, plus or minus the square, and I already have this one down. I already know what b squared minus 4ac is. So it's negative 44. All over, what's 2 times a?
So so 6.
I just grabbed multiply. Okay, so let's simplify this down a little bit. Negative 2 plus or minus. How do I similar to this side? How do I reduce the square root of negative 44?
Take the negative 1 out.
Please, please, please take the negative 1 out first.
And then you do whatever you can do with factoring with the negative or with the 44, which I can't remember for the life of me.
4 and 11.
And 4 is a perfect square, right?
Yep.
So square root of 4, square root of 11, and 11 is prime. So the square root of 4 is 2, the square root of negative 1 is I. So then I'm left with 2I
Square root of.
square root of 11 all over.
Oh. Okay. I remember this.
Now, once again, we want to write our answer as a plus or minus bi, so I do have to split this apart. So I have 2/6 plus or minus 2I radical 11 over 6. And then you can reduce those fractions.
Okay.
And we have it written in our nice, neat little complex form. Doesn't believe you hate that.
Oh, yeah.
I thought it was.
It's a lot of computation.
I don't like dealing with radicals, especially when it's like is that considered factoring?
Well, it's